Here is an example of how you can use circle theorems to find unknown angles. If you look carefully, there are four unknown angles: x, y, c, and a. There is no fixed order in which we can or we have to find these angles. It is for you to determine which angle is to be calculated first, depending on the theorem to be applied. So if I see A can be calculated from this quadrilateral A, B, C, and T. But in this quadrilateral, all three angles are unknown. Only one angle is known. We cannot find A first. We'll have to look other ways to find all the unknown angles in a certain order. So if I look at x, now x is an angle which is made between the radius and tangent. Similarly, y is also an angle which is made between the radius of the circle and the tangent to the circle. Is there a property that relates the angle, that tells you about the angle that lies between the radius and the tangent? Yes, there is, which says the tangent is perpendicular to the radius at this point of contact. Now T is the point of contact of the radius and the tangent, so therefore the angle between these two is going to be 90 degrees. Similarly, OB and BC are meeting at point B, which is the point of contact, which means this angle x made between these two is going to be 90 degrees. So I write x is 90 degrees. Similarly, y is 90 degrees because the tangent is perpendicular to radius. Okay, now we have x, we have y, 90 each. So if you look carefully, in this quadrilateral BOCT, we have three known angles and only one angle is unknown, which is C. So we can calculate this angle C by using the angle sum of a quadrilateral, which is 360 degrees, which means when I add all four angles of any quadrilateral, the answer is going to be 360. So I add all of them. So I get 90 plus 40 plus 90 plus C is equal to 360 degrees. I add them. I get 90 plus 90, 180. 180 plus 40 is 220. So 220 degrees plus C is 360. In order for me to find C, I need to transpose 220 to that side of the equation, which leads to reversing the sign of 220. 220 is positive here. When shifted that side, it becomes negative. So I end up with C equals 360 minus 220. So when I subtract, I get 140 degrees. So my angle C is 140. I have got angle C. Now I'll have to figure out a way to calculate this angle A. Now again, if I see in this largest quadrilateral, I see that this angle and this angle is still unknown. So I cannot use the property of a quadrilateral to find A. Now is there another way? Okay, now angle A is formed at the circumference of the circle, and for the same circle at the center, I can see angle C, and which is calculated to be 140 degrees. Is there a relation between A and C? Yes, there is. Both these angles A and C are inscribed in the same minor arc BT. The relation says, the theorem says, angle on the circumference is half the angle at the center in the same arc. What it says is, the angle at the circumference, which is A, is half the angle at the center, which is C. I write it mathematically. I get A is half of angle C. On substituting the value of C, which is 140, I get half of 140, which is 70 degrees. So that's how I can find all the unknown angles just by using circle theorem. I hope it was easy for you to understand. Thank you.